Hello everybody. In this video session we will see the method that is used to solve the electric circuit, so that is the branch current method. Okay, so in order to understand this method we will solve one problem that will be helpful to clear the concept of this particular method, which is called as branch current method. So this is an electric circuit. So as you can see here, there are three different voltage sources. One is of 10 volt, another is 1 volt, and third one is of 50 volt. Various resistances are connected in different configuration, and here our aim is to determine current flowing through 12 ohm resistance. That is, this particular resistance, how much current is flowing through this resistance, so that we want to determine by branch current method. Okay, so in order to understand this particular method, so we will divide this problem in 6 different steps. Okay, so we will see each step one by one. So step 1, so first step, while solving the circuit, while solving the problem by branch current method, is to give names, at various points. Okay, so we will give the names. So we can use any symbols, A, B, C, D, P, Q, R, S. It is immaterial. So let us say this is A, this is B, C, D, E, F, G, and H. So giving the names is just for simplicity, just for understanding. Okay. Then step 2, so that we have to follow to indicate the polarities of voltage source. Now as you can see, there are 3 batteries or 3 voltage source. Okay, so as you know the sign convention, the long line indicate higher potential, so which we represent by plus, whereas short line we represent by minus. Similarly here, plus, minus, plus, minus. Okay, so that is the second step. Then third step that we have to follow, step 3, is to indicate the current, to indicate the currents and apply KCL. Okay, so in third step we have to indicate the various currents and then we have to apply KCL. Now we will start from the left hand side. Okay, so it is common convention that current always flows from higher potential to lower potential. So we will assume current flowing will be in this direction, I1. Now this current I1, it will flow up to point B, again up to point C, because there is no other path for the current I1 to flow beyond this point B. Okay, so this current again it will be I1. Now here that current will be splitted. Some amount of current will flow through 3 ohm, remaining amount of current will flow through 2.5 ohm. So let us use the symbol I2 to represent the current that is flowing through 3 ohm resistance. So remaining current, if you apply KCL at this node C, so what KCL states that the algebraic sum of incoming current is equal to the algebraic sum of outgoing current. Now here incoming current is I1, out of that I2 is flowing towards node H, so remaining current it will be I1 minus I2. So I will indicate here, so this current as I1 minus I2. So this I1 minus I2 current, it will flow from C to D. Then next, again current will be divided at node D. Now let us say current flowing through 4 ohm, it is I3. Again applying KCL at node D, the remaining current, so incoming current is I1 minus I2. Out of that I3 is flowing through 4 ohm. So remaining current, it will be I1 minus I2 minus I3. Now again at point E, there will not be any bifurcation of the current. So same current it will flow through 12 ohm, that is I1 minus I2 minus I3. Okay. Now we can verify whether we have applied KCL correctly or not. Again, if you see current flowing from F to G, it will be I1 minus I2 minus I3. From this path, current is I3. So this current will be sum of these two current, that is I1 minus I2 minus I3 plus I3, that is I1 minus I2. Again, from this path, there is current I2. So this current will be I1 minus I2 plus I2, that is I1. Okay. So in this way we can cross check. So whatever current is leaving from positive terminal, same current should return to the negative terminal. Again, one more important thing here. So can we consider this current as I2? Yes, it is true. We can consider this current as I2. In that case, this current will be I1 minus I2. Okay, so it is up to you whether we consider this current as I2 or this current as I2, or we can consider current I2 flowing in upward direction also. Okay, but in that case, current flowing through this path CD, it will be I1 plus I2. Okay, so that is the third step. We have to apply KCL at various nodes. Then the next step, step 4. So we have to indicate the polarity of voltage drops across various resistances. Okay, so in next step we have to indicate the polarity. Now to indicate the polarity, we have to remember, so when current enters in a resistance, so when it enters we indicate plus, and when it leaves we indicate minus. Okay, so by this logic, so as we can see, current enters here, so this terminal will be plus, this will be minus. Again, current enters here, plus, minus, again it enters here, plus, minus, plus, minus, plus, minus, plus, minus. That is the next step, step number 4, to indicate the polarities of voltage drops across various resistances. The next step, step number 5. Now in step 5, we have to apply the second Kirchhoff's law, that is Kirchhoff's voltage law, KVL. So apply KVL. Now, how many times we should apply the KVL? It depends on how many unknowns are there. Now, as you can see, here there are 3 unknowns, I1, second is I2, and third one is I3. So number of KVL equations should be equal to number of that particular unknowns. Okay, so here we should apply KVL 3 times. In this problem we should apply KVL 3 times. If there are 2 unknowns, we have to apply KVL 2 times. So apply KVL that many times depending on number of unknowns. Okay, so what we have to understand here, so number of KVL equation is equal to number of unknowns. Now we should apply KVL to various loops. Now as you can see, there are number of loops here, and we should choose 3 loops. Okay, so how to choose the loop? So we can consider this loop A, B, C, H, A, that is one loop. Second loop we can consider as H, C, D, G, H. Third loop we can consider as G, D, E, F, G. Okay. Now suppose if you want to apply another KVL equation for say different loop, for example A, B, C, D, E, F, G, H, A, in addition with these first 2 loop, then also we will get correct answer. But what we should understand here, each and every element, so that should be included at least in one of the equations. So that is the rule that we have to understand. And the last step that is required to solve the problem, to determine the various unknown quantities, is to solve the simultaneous equation, to get the unknowns, to get the unknown quantities. Okay, so these are the various steps that we have to follow. Now we will actually apply the KVL equations and solve this particular problem. So I will rub this part. So our aim was to determine current through 12 ohm resistance. So that was our aim. Okay, so already first 4 steps we have done. So 5th and 6th step is remaining. So we will apply the KVL. Now just for simplicity, we will apply KVL in clockwise direction for these 3 loops. It is immaterial. We can consider anti-clockwise also. Okay. Now let us say this is first loop, loop number 1, loop number 2, and this is loop number 3. Okay. So we will apply KVL to loop 1. So loop is nothing but the closed path. So just for understanding, we have given the different symbols, okay, so that there is no confusion. So loop 1, so how we can write loop 1? It will be A, B, C, H, A. So first loop is A, B, C, H, A. So for this loop, we have to apply KVL. Now sign convention for KVL is that rise in potential we consider it as positive, whereas fall in potential we consider it as negative. Okay. Now we will move from A to B. So as we are moving from minus to plus, so there is rise in potential or rise in voltage. So it will be plus. Now as it is the voltage, so we don't multiply by current. So it is plus 10, because what is KVL? Algebraic sum of voltages in any closed loop is 0. Okay. So here it is voltage plus 10 plus. Now next we are moving from plus to minus, that is higher potential to lower potential, means there is a decrease in voltage. So there will be minus sign, minus 1 into I1. Now why we have multiplied 1 into I1? Because voltage across this resistance by Ohm's law it will be I into R. So value of current is I1, whereas resistance is 1. So it will be 1 into I1 plus, then plus to minus, again there is fall in voltage, so minus 2 into I1, current is I1, plus, then this path C to H, so plus to minus, meaning there is fall in voltage, so minus, value of resistance is 3, current is I2, minus 3I2, plus to minus, now there is decrease in voltage, fall in voltage, so it will be minus 1. Now we should not multiply this 1 with current I2 because it is the voltage source. Okay, so that we should be very careful. Minus 1, that will be equal to 0. Now just mathematical simplification we will do. So here minus I1, minus 2I1, it will be minus 3I1, minus this term 3I2, then plus 10 minus 1, it will be plus 9. On that side if we take, it will be minus 9. Okay, we can divide each term by minus 3. So our equation will be I1 plus I2 equal to 3. That is our first KVL equation, I1 plus I2 equal to 3. Now similarly we have to apply KVL for 2 more loops. Okay, now we will apply KVL to second loop. So apply KVL to loop 2. Now what is the second loop? Here as you can see, H, C, D, G, H. So that is our second loop. So in bracket I will write H, C, D, G, H. Okay, so we should apply KVL to that particular loop. Now while moving from H to C, first there is the voltage source, minus to plus, means there is rise in voltage, plus 1, plus, again we should not multiply this one with the current, okay, because it is the voltage source, plus, again minus to plus, means there is increase in voltage, so plus 3, current flowing is I2, plus, now from C to D, there is decrease in voltage, so minus value of resistance is 2.5. now how much current is flowing through this resistance 2.5 ohm? It is I1 minus I2. So 2.5 multiplied by I1 minus I2. Then plus to minus, again there is fall in voltage, so it will be minus, value of resistance is 4, current is I3, so minus 4 into I3 equal to 0. Okay, now we will simplify this. So 1 as it is, plus 3I2 minus 2.5 I1 plus 2.5 I2 minus 4I3 equal to 0. Okay, so we will combine all terms of I1 together. There is only one term of I1 minus 2.5 I1. So how many terms of I2? So 3I2 plus 2.5 I2, that is 5.5 I2 minus 4I3 equal to minus 1. That is our second KVL equation, equation number 2. Now we have to apply KVL one more time, because as we have seen in step number 5, number of unknowns and number of KVL equation, they should be same. Now third loop we will consider. So apply KVL to loop 3. What is third loop? So third loop is G, D, E, F, G, because here we have followed the convention, that is we are applying KVL in clockwise direction. Okay, so this will be G, D, E, F, G. Now from G to D there is one resistance, we are moving from negative to positive, there is increase in voltage, so plus 4 into current is I3 plus, next from D to E plus to minus, that is fall in voltage, so minus 1 into current is I1 minus I2 minus I3. Then next E to F plus to minus, again there is fall in voltage, minus 12 into I1 minus I2 minus I3. And finally, while moving from F to G, we are moving from negative to positive, means there is increase in voltage, so plus, I will write here 50 equal to 0. We should not multiply I1 minus I2 minus I3 into 50, because it is itself is the voltage source. Okay, now we will simplify this. Okay, I will just rub this part. So if you simplify, so 4I3 as it is. Now in this second and third term, minus I1 minus I2 minus I3 is common, so we can take that term as common. So minus 12 and minus 1, it will be minus 13 in bracket I1 minus I2 minus I3 plus 50 equal to 0. Again we will simplify this bracket, so it will be minus 13 I1, then plus 13 I2 plus this 13 I3 plus 4 I3, so it will be 17 I3 equal to minus 50. This is equation number 3. So we have got 3 equations. So first equation, I1 plus I2 equal to 3. Second equation, minus 2.5 I1 plus 5.5 I2 minus 4 I3 equal to minus 1. And third equation, minus 13 I1 plus 13 I2 plus 17 I3 equal to minus 50. Now as we know, we can solve these 3 equations by using Cramer's rule, or we can directly solve these 3 equations on calculator. Okay, now if we solve these 3 equations on calculator, we will get the 3 unknowns as, so I will write directly. So I1, it is equal to 2.7229 ampere, I2 is 0.2770 ampere, and I3 it is minus 1.6 0.070 ampere. Okay, after solving these three equations, either by Cramer's rule or by directly using the scientific calculator, we can determine these three unknowns, I1, I2 and I3. Okay, now here very important thing, I1 we are getting as positive, I2 we are getting as positive, but I3 we are getting as negative. Now what is meaning of positive sign and negative sign? So whenever we are getting the positive sign, meaning is that whatever assumption that we have done, it is correct. For example, we have assumed I1, it is flowing from A to B, or it can be said that this particular battery it is discharging. So that assumption is correct because here there is plus sign. Then second, I2 is also positive, that is current I2 it is flowing from C to H, it is also correct in this direction, C to H direction, that is also correct because here we are getting plus sign. But here I3 is negative, meaning is that we have assumed current is flowing from D to G in this direction, but actually current is flowing from G to D. What is the magnitude? Magnitude will remain same. So our answer is correct. Only thing, whatever we have assumed that current is flowing from D to G, that is in downward direction, so that is not correct. Actual current is flowing from G to D. But while solving the problem, we should keep same sense. Okay. Now what is our main aim? We want to determine current through 12 ohm. Now how much current is flowing through 12 ohm resistance? So how much current is flowing through 12 ohm resistance? It is I1 minus I2 minus I3. So we will determine that current. That will be the last step. So current through 12 ohm resistance, it is I1 minus I2 minus I3. Now we have obtained three unknowns. So I1 is 2.7229 minus I2 is 0.2770 minus, now as I told, we have to keep same sign whether we are getting positive or negative. Okay, so here we are getting negative, so we have to keep as it is, minus 1.070. Now if you simplify this, now this will be 2.7229 minus 0.2770 plus 1.070. So its final answer, it will be 3.5159 ampere. Now again look towards this sign. As here there is the positive sign, meaning is that whatever our assumption that current flowing through 12 ohm, it is from E to F, it is correct. So we can write that. So current is flowing from point E to F. So this is our final answer. Okay. So by using this particular method, which is called as branch current method, and following these 6 steps, we can determine any unknown quantity. Suppose if you want to determine voltage across 12 ohm, so only one thing we have to do, already we have determined the current multiplied by the resistance. So 12 into this term, that will be the voltage. If you want to determine current through 4 ohm, it is I3. If say we want to determine power consumed by 2.5 ohm, then it will be this current square, that is I1 minus I2 square multiplied by the resistance, that is 2.5 ohm. So by this method we can determine any unknown quantity, whether it is current, voltage or power. Thank you.